Bismillahirrahmanirrahim. Today, inshallah, I shall speak about ellipses or singular ellipse. So, before us, we have an ellipse, okay? And there are two types of ellipses, okay? The one that's over here, this is called a horizontal ellipse. And it's kind of like laying flat. Now, if you were to draw an ellipse that's like this, that would be a vertical ellipse, okay? Horizontal, and that would be a vertical. It's very intuitive description, correct? So there are two types of ellipses, okay? There's the horizontal ellipse, and there's the vertical ellipse. So you can imagine this an ellipse as having a length and a width, so to speak, right? Now these are given names, right? So these are given names. The longer length, so to speak, here, okay, is that, and the shorter length over here is this, okay, and they're given names, okay. So the longer length, that's called the major axis, okay, and the shorter length is called the minor axis, okay. So the major axis and the minor axis. So a horizontal ellipse, okay, is where the major axis is horizontal, and the vertical ellipse is where the major axis is vertical. So if you imagine a vertical ellipse, right, the major axis, of course, the longer length would be vertical, and hence that's why it would be called a vertical ellipse. Fair? Okay. So that's how you tell it, if it's a major or a horizontal or vertical ellipse. Okay. So now, why is this a horizontal ellipse? Well, it looks like it's like sleeping. I know you can't say that. You have to say where the major axis is horizontal, and vertical ellipse is where the major axis is vertical. So these are the two major axes. Okay. Now, half of the major axis is typically given a name. Okay, and you can call it A. So from here to here, half of the major axis is typically given a name with a variable like this, so you can call it A. That too is given a name, okay, it's called half of a major axis. Well, it's not called half of a major axis, it's called semi-major axis, okay? So A would be half of the major axis. You can call it semi-major axis. So A is the length of the semi-major axis, and B is half of the minor axis, or you can call it semi-minor axis. So if, for example, if the whole thing was from here to here, from one end of this ellipse, so to speak, to this other, and if the whole thing was 10, A would be 5. It would be half of the major axis. Now, it's important not to get overwhelmed with terminology, but I think it's when you're studying it formally, at least one time you have to be introduced to it in a proper way. Okay. Where the major and minor axis meet, okay, the meeting of the major and minor axis, which is right here, that point right there, that's called the center of the ellipse. Okay, so this point C here, okay, is the center of the ellipse. Now, for us, this is going to be the Vx and Vy, or the pseudovertex, so to speak, okay? So that's the center of the ellipse. Now, an ellipse has vertices. An ellipse has vertices, all right? And they are here. Okay, so it has actually 2 vertices, not 4. Okay, so these are called vertices, or singulars is vertex, and that's a vertex. Now these over here, they're not called vertex, they're called covertices, or singular covertex. Sometimes they're given different names by different people. Covertex. Alright? So again, so to write it in a more simplified way, it would be like this, as I've labeled over here: vertex, vertex, covertex, or sometimes they're called minor vertices. Okay, you get the idea. So far the terminology that we have learned is that there are two types of ellipses, horizontal ellipses and vertical ellipses, and that's determined by the major and minor axis orientation. If the major axis is horizontal, that's a horizontal ellipse. If the major axis is vertical, that's a vertical ellipse. Now half of the major axis is this length over here that's given a name that's called a semi-major axis, and half of the minor axis is called a semi-minor axis, and they're given names typically A and B. Okay, where the two ellipses meet, that's called the center. Okay, which they should have probably labeled this as center over here. So, okay, and then an ellipse has two other important points. An ellipse has two foci, and that's over here. I think they're like about there. So F1 is the first foci. Now, some call it foci, I call it foci, tomato, and focus is singular, foci is plural. So F1 is one focus, F2 is two focus, and together they make foci. Now, they are very important, okay? They're an important factor. That's how the ellipse is generated using a foci, okay? So, to complete this thought, we have to add one last thing over here. Okay, the distance from the center to each foci, that's usually given a name, C. So this distance is C. Okay, now I just want to make sure that we appreciate, okay? So this is A. Okay, let me just use red, since we use red. Make some shade of red. Alright, so this is A, and this is B, okay, that length from center to the vertex, and it's very imperative for us to appreciate that from here, from the foci to the center, that is C. From here to here, that is C. Okay, now you have to understand that A is bigger than C over here, right? Correct. So so that's the basic terminology of an ellipse. So C is the distance from center to foci. Now in this stencil drawing that I found, they unfortunately labeled the center with the capital letter C, and remember, distance is typically lowercase letters. It shouldn't cause too much confusion, but nevertheless it does. So we're just going to ignore this center. Okay. The key thing is to understand that A is the distance from center to one of the ends, B is the distance from center to the other end, and C is the distance from the center to the foci. Those are three very important elements of an ellipse. Okay? So there we have it again. So A is from the center to this end, and B is from center to a semi-minor axis here, and C is from center to the distance from center to each of the foci. Now we're going to talk about the definition of an ellipse. Okay, like we had a definition for parabola, we had a definition for a circle. Inshallah, we have a similar definition for this conic section, the ellipse. So an ellipse is a set of all points. Now this is an ellipse that's in a Cartesian plane, right? So it's going to have every point on the ellipse is going to have an ordered pair, x and y, as on the Cartesian plane, right? So an ellipse is a set of all points such that, okay, the distances from that point, let's call that point P, the distance from that point to the foci remains constant. Okay, for example, let's say from this foci to this point, let's call this distance D1, and from this foci to this point, let's call that distance D2. Okay, now that distance, okay, that's going to be constant. Okay, so D1 plus D2 is going to be a constant. It's going to be the same for any point on the ellipse. If let's say if you have another point over here, so let's gather this and let's gather that. Let's call that's D3 and D4. Okay, so this distance is going to be equal to d3 plus d4, that's going to be a constant. And if you, let's pick another point like over here, and so, sorry, this distance from this focus to that point, and that is going to be the same. Okay, so let's call, we have 4, so d5 and d6, so that's going to equal to d5 plus d6. And let's, just for the heck of it, let's pick another point over here on this side of the ellipse. So from that distance plus this distance is the same. Okay, d7 and d8. So this distance is also going to equal to d7 plus d8. So in other words, an ellipse is a set of all points such that the sum of the distance from that point to each foci is constant. Okay, to illustrate that, we have this picture here. So here you can see the two foci, and this is a point. And as you can see, just the point goes around. The distance is going to be remain constant. Okay. In this case, this is another horizontal ellipse. Okay, and so the ellipse is the red structure here, and it's a set of all points whose such that the distance from that point to each foci remains constant. Okay, you can generate an ellipse like pretty easily like this. See, in this case, as you can also see, the distance between the point on the ellipse and the two foci is going to remain constant. Okay, it's going to remain constant. Okay, so I'm going to write for you here the general equation for an ellipse. The general equation for an ellipse. Okay, and just to label this, the center V is going to be Vx and Vy. This is the vertex. Okay, that's our affectionate terminology. Okay, so the general equation for an ellipse is going to be like this. Okay, x minus Vx squared over a squared plus y minus Vy squared over b squared is going to equal to 1. Okay, that's the general equation for an ellipse. Okay, let me rewrite this and just do this together, and you'll notice x minus Vx squared over a squared plus y minus Vy squared over b squared equals to 1. Now, compare this to the equation of a circle. Okay, x minus Vx squared plus y minus Vy squared equals r squared. Okay, so it's very similar, but the denominators are different here, and there's a 1 over here. Now, if you were to divide the circle equation by r squared, in other words, if you were to divide everything by r, like this, okay, by r squared, if you divide the whole equation by r squared, then you would get x minus Vx squared over r squared plus y minus Vy squared over r squared equals 1. Okay, and that's basically identical to the ellipse, except for a and b are the same. In other words, the major and minor axes for the circle are equal, and that's why it's a circle. So a circle is a special form of an ellipse, as you can easily extrapolate from your understanding, right? But the general equation for an ellipse is as I have written here, and the general equation of a circle is as I have written here. Now, I do want to caution you on a couple of things. One is that many textbooks label the center as H and K, but we are used to this, so we're going to continue this, and you can easily have confidence, you can easily substitute those if necessary once you appreciate the values of what they stand for. The second thing I caution you is that many textbooks have two different equations for ellipse based on whether it's a horizontal ellipse. So they have one equation for a horizontal ellipse and one equation for a vertical ellipse. Okay, and that I think is not necessary. And I just remember one equation, and if you understand that equation, you can apply the same equation for both. Now, what I mean by that is they would have, for example, an equation like this. Now compare these two equations. X minus bx squared over b squared plus y minus by squared over a squared. What has happened is basically they have flipped this over here, okay? And they would say that this is the equation for a vertical ellipse, okay? Now, that's redundant. That is just confusing the poor student. At least it would confuse me. But the idea is to understand it is a is the bigger number, okay? If a is over here, wherever the bigger number is, that's the a, because a, by definition, as I've defined it, is the length of the semi-major axis, okay? So I'll give you two examples to illustrate my points, okay? So x squared, over 25 plus y squared over 16 equals 1. Now this is an ellipse, okay? This is an ellipse. Now I put 0 and 0 for x and y. So this is an ellipse that's centered around the origin. But this would be the A. So this is a horizontal ellipse, okay? Now if I had written this, x squared over 16 plus y squared over 25 equals 1, okay? This would be the A, because A is the larger of the two semi-axes, okay? So this would be a vertical ellipse, okay? So, it confuses students, but the thing to remember is A is the bigger of the two semi-axes, so you have to figure out which one it is. Now when we do more examples of this become readily apparent, okay? Now, whichever one is the bigger number, that would be A, and that's important because foci will always be only on the major axis. Foci will always be on the major axis. Foci will not be on the minor axis, okay? So if it's a vertical ellipse, the foci will be on the vertical axis, okay? Now, so this kind of lays the foundational knowledge for us to talk about and discuss some examples of ellipses. And we shall build upon this next time. Then, until then, as-salatu was-salamu ala sayyidina wa ala alihi wa sahbihi. Assalamu alaikum.